Well, hello. Welcome to another flip lesson dealing with logarithms. Now, yesterday we took a look at solving equations that already had logarithms in them. And today we're going to take a look at how we can actually introduce logarithms to an equation where there were no logarithms to begin with to actually make it easier to solve that equation. And I know right now what you're thinking. You're thinking, oh, Mr. Breath, you're violating the second rule of mathematics, or of logarithms, which is logarithms kind of suck. But look at these problems here, and we're actually going to see how logarithms will make a difficult problem kind of easy. So let us behold the awesome power of logarithms. Look at problem number 1 right here. 5 to the x equals 27. Well, notice we cannot write 27 as a power of 5. Now I can guess what x is. I know x is between the numbers 2 and 3 because 5 squared is 25, which is a little less than 27, and 5 cubed is 125, which is more than 27. So I'm going to guess that x is a number slightly bigger than 2, but that's not really solving. That's just kind of estimating what x could be. Now notice that x is an exponent. And what are logarithms? Well, they're exponents. So what I'm going to do is I'm going to introduce a logarithm to this problem. Now ultimately I'd love for my logarithm to be a base 5 logarithm, but my calculator only has 2 logarithmic buttons on it. It has the common log and it has the natural log right below it. So what I'm going to have to do is introduce one of those 2 logarithms. And it doesn't matter which one. So in this first example, I'm going to use the common log, log base 10. So I took the logarithm of both sides. Now, what's that allow me to do? Well, one of the special characteristics of a logarithmic function, and only logarithmic functions have this characteristic, is I can take this exponent and bring it down with everybody else. No other function has that characteristic. No other function lets me grab exponents and bring them down to everybody else's level. And if I do that, well, look now. X is at the same level as everybody else. And if I want to get x by itself, I simply have to undo this multiplication with some division. So I divide both sides by that fairly ugly number, common log of 5, but that's not my problem. That's my calculator's problem. So I go into my calculator and I simply type the common log of 27, close your parentheses, make sure you close your parentheses, divided by the common log of 5. And that's going to give me my answer here of 2.048. So I now know that x is about 2.048. We estimated it to be slightly bigger than 2, and that's what we got. And as a matter of fact, the beautiful thing about these calculators is I can check my answer super quickly. Go back to the original problem. Just take 5, raise it to that number. I'm going to use the answer button in my calculator, and voila, I get 27. So why don't you try to solve problem number 2. Pause the video, take just 60 seconds, see if you and your calculator can get through problem number 2. Hey, welcome back. Hopefully you introduced logarithms. You'll see when I did number 2, I introduced the natural log instead of the common log. Again, it doesn't matter. Your calculator can handle both. You just have to be consistent. If you use the natural log on the left, you've got to use the natural log on the right. And when you solve this and you divide both sides, where's that division? You know it's there. Anyway, divide both sides by the natural log of 3, you get x is about 3.465. Again, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. I'm expecting this to be between 3 and 4 because 3 cubed is 27, 3 to the 4th is 81. Boom, that's what I got. And using logarithms, really in this case, is very special because it lets us grab that exponent and bring it on down with everybody else. Let's take a look at two new problems here. Let's take a look at problem number 3. Now again, you'll notice that the variable is trapped in the exponent. So we're going to want to bring logarithms into play, but not right away. Do not bring a logarithm into play until the base is isolated, until the base is all by itself. And this 3, nope, it's not by itself. It's got that 4 hanging out there. So I got to get rid of that 4. Now I can't multiply 4 by 3 because, you know, order of operations. Exponents take precedence over multiplication. So I'm going to just divide both sides by 4. And this allows me to get the left-hand side, 3 to the x. The base is isolated. And on the right-hand side, we have 16. Now is the time for logarithms. 16 is not a power of 3. So I can't just rewrite 16 as a power of 3. Instead, I'm going to introduce a logarithm to both sides. And that logarithm gives me the power, see the power, a little joke there, to take that x and bring it on down with everybody else. As a matter of fact, that's called the power property of logarithms. By the way, you'll notice I start to use the natural log more than the common log, simply because natural log involves 2 letters, common log involves 3. I figured it's a little bit more efficient. So now that I bring the x down with everybody else, I have x times the natural log of 3. I can get both sides. I could divide. Where's my? Nope. I could divide both sides. Where is it? Divide. This is really frustrating. I could divide both sides by the natural log of 3, and boom, there's my value of x. Number 4. Very similar to these problems, except you'll notice the exponent here is an expression. It's not a single number, it's an expression. So 6 is not a power of 2. I can't rewrite 6 as 2 to some power. So again, this calls for logarithms. I use the natural log. I'm kind of drawn to the natural log again, 2 letters instead of 3. And whoops, little typo there, that x doesn't belong. But now that I took the natural log of both sides, just ignore that typo, I can take my exponent here and I can bring it down. Now be very careful when you bring this x minus 1 down with everybody else. Be very careful. We end up getting the natural log of 6 equals the quantity of the natural log, the quantity of x minus 1 times the natural log of 2. Now, be careful here. What are you going to do? There are really 2 ways you can handle this. One way is you could distribute this natural log of 2. You could distribute it into that group of parentheses. And if you do, you would have this. And then I'm trying to get x by itself. You'll notice I can add the natural log of 2 to both sides. And then I could divide both sides by the natural log of 2. My focus is on getting this x by itself. And that's what I get for x. Now, having done that, there is another way you could have worked this problem, all starting from right here. Instead of distributing that natural log of 2, you could have done something else. And it's worth your time to play around with that. See if you could figure out what else you could have done. And if doing that would give you the same answer as what we got right here. So maybe you pause the video, talk it over with your little buddy. Let's do a problem that's a little bit more fun. Oh, look at this one. This looks like a lot more fun. How do we do this? Well, again, 2 and 3, those are 2 different bases. Variables are trapped in the exponent. I'm going to introduce a logarithm. I'm going to do natural log again. I'm kind of partial to natural log. Now that I have a logarithm involved, I can take this exponent, the whole exponent, and I can bring it down. Same on this side. I can take this exponent, and I can bring it on down. Let's see what we get. Now remember, it's the quantity, the whole exponent of x plus 3. Times the natural log of 2. It's the whole exponent quantity of x minus 1 times the natural log of 3. Well, now it's time to let your Algebra 2 skills shine. I'm going to distribute the natural log of 2. I'm going to distribute the natural log of 3. And I end up getting this. And oh my gosh, my nice, succinct, beautiful equation is getting really big. But let's not lose sight of our goal. Our goal is to get the x's by themselves. And there's an x right here, and there's an x right here. I want those x's together. I'm going to move them to the left side. I'm going to take this 3 times the natural log of 2, move it to the right side. I want my x's together. And now I'm stuck. Oh my word. Look at this. I can't combine them. They're not like terms, even though they both have an x. This is the natural log of 2. This is the natural log of 3. So close. I have the x's on the same side. Oh, this is frustrating. Oh my word. What am I going to do? I might just say it. It might be time. I'm going to say it. I'm going to say it. I'm going to say the F word. We got to factor. We have got to factor this thing. I'm going to go ahead. Get away from there. I'm going to go ahead and I'm going to factor. I'm going to take an x. I'm going to take an x and I'm going to pull it out. And when I pull that x out, look at what's left behind. Whoops, don't look at that. Look at what's left behind. I seem to have lost my stuff. Oh, there it is. There it is. Okay. I don't know. Something happened there. When I pull that x out, look at what's left behind. This ugly beast, this ugly beast right here is left behind. And x flew out. Natural log of 2 minus natural log of 3 is left behind. That's okay. That's okay. Don't panic here. All I have to do now is I have to divide both sides by this natural log of 2 minus natural log of 3. So I go ahead. I seem to have lost my. I go ahead and I type that in my calculator and I get x is about 7.838. I know we kind of had a little malfunction in the smart software here, but that idea of factoring, that idea of pulling out that GCF, oh my heavens, that is a great algebra trick to have. Well, here's another problem, and I want you to pause the video. I want you and your special buddy to work this one together. See if you can get that answer. And if you can, you're ready for the homework.